So in this question here, I've got 12 six-sided dice, which I'm going to throw all at the same time. And what I want to know is what is my chances of getting exactly 7 of those dice to score greater than 2. So not 8, not 10, not 4, it's got to be exactly 7. So what's the chances of that happening? So first of all, let's analyse the question in a few details. First of all, we've got a dice with 6 outcomes. So we want to know the score greater than 2. So 2 is not invited into that selection process. So it's 3, 4, 5 and 6. So there's 4 possibilities. So 4 possibilities out of 6 choices. My probability of 1 dice is 2/3. Now for a question like this, I'm also going to need the probability of it not happening. So the probability of it not happening, which is 1 minus p, is 1 minus 2/3, which is 1/3. And I also need to know the number of trials. So the number of trials is when I'm looking at it, I'm going to be analysing my 12 dice. So each one will be a trial to see what would happen. So the number of trials in this question would be 12. And also we're looking for each dice to have a score greater than 2. So there's only 2 outcomes. Or the score is greater than 2 or the score is not greater than 2. So with that, and assuming that all this is independent and there's no cheating going on, we can assume to use the binomial distribution. So if I write that down, binomial distribution. And what we do when we have a binomial distribution situation, we write this in terms of its mathematical grammar. We say x is distributed, so x distributed, that's our random variable, b for binomial, and there's 2 parameters in this distribution. Number of trials, which is n, and p, which is our probability. That's how we would note it. So in this case, we've got number of trials is 12 and p is 2/3. So for this particular example, it's 12, 2/3. That's how we'll write it for this example. So that's going to define how we would calculate our probability for this question. So the next thing we need to know is the binomial distribution, which is very similar to the binomial formula. So what we write is a probability that x equals lowercase x, so x as in capital letter and x as in algebra x. So in this case, x is going to be 7. So we're looking for x equals 7. And then that's written as n choose x. So that's like the binomial coefficient formula. And then we have p to the x, and then multiply that by its opposite, which is it not happening, 1 minus p, and that's to the n minus x. So we know what p is, we know what 1 minus p is, x is 7 and n is 12. So we've got all the building blocks to build up our probability for this question. So first of all, let's just have a look at n choose x. So for n choose x, the formula for that is n factorial divided by x factorial times n minus x factorial. So in this case, if I write down this in terms of all its numbers, we can come back to this. I'll leave a little gap here just to deal with this. So probability x equals 7, that's our case here. N choose x, that's 12 choose 7. And then we got p, which is 2/3. And to the x, which is our 7. So these numbers will always match. And then for the 1 minus p, I'm just going to write that as 1/3. And that's to n minus x, which is 12 minus 7, which is to the power of 5. So here, I've got my n's and my x's. So that would be 12 factorial divided by x factorial, which is 7 factorial, and n minus x factorial, which is the same as this one, which is 5 factorial. So you could write all these out as 1 times 2 times 3 times 4, so on, and the same with this, and multiplied by this. That would then end up with 12 times 11 times 10 times 9 times 8, all divided by 1 times 2 times 3 times 4 times 5. And that will get us to some way to being a lot more simple. Now I want to show how to do this without a calculator. So I'm going to simplify this all off. So what can I cancel out? Well, I've got a 5 and a 10, so that's gone, and that becomes a 2. I've got a 4, which could go with the 8, that would be good. So that would go, and that would just become a 2. I've got a 3, which could go with a 9. That will go, and that'd be a 3, so these are all multiplied. I've got a 2, which can go with the 12. So then I've got 6 times 11 times 2 times 3. So I've got 6 11s are 66, times 2 is 132, times 2 is 264, and 264 times 3 is 792. So this would be 792. You can type this into your calculator as well with the n choose r function as well. It may look like that. So now my building blocks for this are nearly done. So now I've got 792 times, now there's a nice easy way we could write this. 1 to the power of 5 is just 1, so nothing to write. But I've got 2 to the power of 7, which I can calculate. 2 to the power of 7 is 128. And then divide that by basically 3 to the power of 7 and 3 to the power of 5 multiplied together is 3 to the power of 12. Okay, so now 3 to the power of 12, I could write that as 792 times 128 divided by, well, I could take that to the power of 4 because that's 81 and then cubed it. So 81 cubed. And then if I put that into my calculator, I'll get approximately 0.1907566629. We could just put that as 0.19. That would be good enough for me. 0.19. That would be to 2 decimal places. Okay, so that's our probability of getting 12 six-sided dice to score with 7 dice exactly greater than 2. So that would be my final answer, and that's my rounded part as well there. Okay,